Mitchell, that's Eduardo Zuniga, and that's Mario Vargas. We're Team AOP, Autonomous Organization Platform. All right. What we're doing is building and programming a robot that'll be able to scan a color. Once it scans that color, it'll know to go to a corresponding workspace. It'll go to that workspace, drop off the product, head back home, and repeat the whole product. This is a technology that's used in big storage companies, used for organization. Mario was in charge of construction and the main programming of the robot. Eduardo was in charge of the construction of the workspace as well as of the stand. I was in charge of researching and programming the codes. This is what our product looks like, as you can see it right here. What it does, an object is placed in front of it. It scans the object, detects what color it is. It picks up the object, goes into the workspace. The ultrasounds will find an object. Once it goes up to that object, what color it is. If it's the correct color, it'll drop it off and head back to the workspace. This is an existing product. What this one does, programmer right there tells it what color to find. It goes, finds the color, and drops it off at the product line. This is the same thing except a two-part product. It's programmed right there, it drops it off, and these robots right there will pick up the color and start programming it.
Actually, there's already, like Aaron mentioned, there's already some existing products. There's a company, Zappos. It's an online internet company that you can go purchase shoes, clothes, whatever they have. This is actually their warehouse. As you can see down there, below the shelf is the actual robot that they use. That robot, when it gets a command from the cashier or the person that's purchasing the order, actually goes, picks up a whole shelf, brings it to that person. They take what they need, and they bring it back to wherever they got it from. From that picture, you can actually see the robots themselves.
Okay, we got our idea, kind of seeing this type of robots. They thought of this, but instead of putting a camera, as it seems on the first one, we decided to put color sensors, so nobody has to be on top of the camera in the videos, and with a bigger gripper. So we decided to work with a Bobot because it's a prototype we're using. The gripper fits the size of the Bobot, and also it's inexpensive. It's not that expensive to work with. That's the Bobot without any sensors. This is halfway through. We got the gripper installed, the IR sensors, but after that we installed the other parts. These are the components. Basically, the first one, the basic stamp, DB, and the third one, the cable extension cable, are for the color sensor because this is not made for the BS2, so we needed an adapter. Basically, the gripper, the ultrasound sensor. This is the PIR sensor, the motion sensor. We did not use that. We had it, and the QTI line follower sensor. This is how the Bobot actually looks upside down. 3 QTI sensors, the line sensors, and this is how they work. They detect colors white and black are the most contrast colors. So when it detects a white color, it's going to be 0. When it's a black color, it's going to be 1, and that's how you program it. This is a light colors, the color sensor. How you can see there, they have 2 lights, which illuminates for the lens on the middle to detect the actual color. The color sensor has to be pretty close, an inch more or less of the object we're detecting, so it can be more clear. These are the IR sensors, the receiver and the transmitter. This is just to detect the box or whatever object it's detecting. To open the gripper, that's the side. And this is the ultrasound sensor. We put it on top, so it detects the actual where is supposed to leave the object, the boxes, the distance.
Now, from what you see there is the actual programming for the QTI sensors. Here we'll actually show you a video of it. We'll show that video towards the end when you actually see the whole.
And I said before, 0 is going to detect when the line sensor is in the light. 1 is going to detect when the line sensor is in the dark. This is a flow chart of how the program reads. See, the second one shows when it's lined up exactly in the middle, so it's only detecting darkness in the middle, therefore it knows to go forward. If it sees 2, it's one way. For example, the third one says 2 1s, that means it's a little bit towards the right, so it just needs to pivot a little bit towards the left. If it just has 1 with 2 zeros, that means it's faced too much to one side, so it's going to make a bigger turn to the other side.
Alright, for the color sensor that we have in the front, it basically reads red, green, and blue, like most of our monitors do, and it shows one color on the screen. From the screen, actually you can see it's 2 different colors. First row is red, second is green, last is blue. Over here, you can actually see the colors mixed, and right here in the middle is actually the color that it was looking at.
This is a flow chart of the colors once it reads the colors. Scan the object. Once it scans the object, it's then going to pick up the color and it's going to head to the workspace. For example, if it detects a black object, it's going to pick it up and it's going to detect what color it is. It's going to be black. It's going to look into the workspace until it finds the black object. It's going to then drop it off, back up, return to the track, and repeat the whole process over.
Now, from earlier, the color sensor actually is not made for this board, so we needed to buy the adapters that you can actually see the color sensor just hang there. It's not actually attached to anything, so one of the improvements that we needed to do was for the color sensor and also add an additional ultrasound that you actually see in the next one. That is actually what we have here, what the final looks like. Here we actually pinned the color sensor to it, and back there the ultrasound is hanging at the top so it can see basically the objects in front of it. This actually concludes our presentation.
We're going to scan the red object, and then what it's going to do is going to pick it up and hit the designated drop-off spot, come right back, hit the track, and do the whole thing over again. Right now, sees the designated drop-off spot has hit. That's exactly where it's supposed to drop it off. And it's going to do the whole thing over. What me and my partner are going to do, we're going to turn this around. That way next time it hits this designated work spot, it's going to be a different color. And then you'll see what it does from there. Scan red in front of it again. Spot, and you see it does something completely different. From here it sees it's red. What it does is it drops it off, comes right back to the track, and it repeats the whole process over again. All right? We can do this with different colors, different applications if we want, but for this project we just decided to stick with the red and the black. That way we just show you the purpose of what it's supposed to do. And right there it's going to stop. Found it.